On a rainy afternoon in a cozy coffee shop, two students, Aria and Jaxon, engage in an in-depth discussion about databases and database management systems for their assignment. So Jaxon, our assignment is on databases, right? Can you explain what databases are and what a database management system is? Sure, Aria. A database is a structured collection of data that allows us to store, retrieve, and manage information efficiently. Think of it as a digital filing cabinet where we can keep all our information organized. Databases can store various types of data, including text, numbers, images, and even multimedia files. Aria, I get that. But what about a database management system, or DBMS? A DBMS is software that interacts with the database, users, and other applications. It helps manage the database by providing tools to define, create, maintain, and control access to the data. It ensures data integrity, security, and efficiency. For example, a DBMS handles tasks like data backup, recovery, and enforcing data security protocols. It also provides an interface for users to interact with the database using queries. Aria, that makes sense. Databases sound crucial, especially with all the data we deal with these days. What are the fundamentals of databases? At their core, databases consist of tables made up of rows and columns. Each table represents a different type of data, and each row represents a record. The columns are the attributes that define the data. For example, in a customer database, you might have a table where each row is a customer, and columns for their name, email, phone number, and address. Additionally, databases use indexes to speed up data retrieval and primary keys to uniquely identify each record. Foreign keys are used to link tables together, establishing relationships between different types of data. Aria? Got it. Now I remember reading about different types of databases. Can you explain the main types? Sure thing. There are two main types, relational and non-relational databases. Relational databases like MySQL, PostgreSQL, and Oracle use structured query language, SQL, to define and manipulate data. They organize data into tables that can be linked or related based on data values. These databases enforce ACID properties, atomicity, consistency, isolation, and durability, which are essential for reliable transactions. This ensures that all database operations are processed reliably and ensure your data integrity. Aria and non-relational databases? Jaxon, non-relational databases, also known as NoSQL databases, like MongoDB, Cassandra, and Redis, don't use a table-based structure. Instead, they use various data models like document, key value, column family, and graph. Document databases store data in JSON-like documents. Key value stores manage data as key value pairs. Column family stores organize data into columns, and graph databases focus on relationships between data points. These databases are designed to handle large volumes of unstructured or semi-structured data and provide high scalability and flexibility. They are often used in big data and real-time web applications. Aria, interesting. So, how do these databases fit into the bigger picture of information technology? Jaxon, databases are fundamental to IT because they store the critical data needed for applications to function. Everything from web apps to enterprise systems relies on databases to store user information, transaction records, and other vital data. They support data analytics, business intelligence, and decision-making processes. For example, e-commerce websites use databases to manage product catalogs, customer orders, and payment details, while social media platforms use them to store user profiles, posts, and interactions. In healthcare, databases manage patient records, treatment plans, and medical histories. Aria, that explains why we need to understand them well. How about database administration? What does that involve? Database administration is a critical aspect of managing databases. It involves tasks like installing and upgrading the database server, configuring the database environment, and managing user access. Database administrators, DBAs, are responsible for ensuring the database is available and performing optimally. They monitor the database for performance issues, apply patches and updates, and plan for capacity by analyzing storage and computing needs. DBAs also implement backup and recovery procedures to protect against data loss and ensure that the database is secure from unauthorized access. Aria, that sounds like a lot of responsibility. Are there any specific tools or techniques DBAs use? Yes, DBAs use various tools and techniques to manage databases efficiently. For example, they use monitoring tools like Nagios and Oracle Enterprise Manager to Keep an eye on database performance and health. For backup and recovery, they might use tools like RMAN for Oracle databases or MySQL Dump for MySQL. DBAs also use scripting languages like Python and Shell to automate routine tasks and manage configurations. They follow best practices for database tuning, such as indexing strategy, query optimization, and hardware resource allocation to ensure the database runs smoothly. Aria, these best practices seem essential for maintaining a reliable and secure database system. What are some other best practices we should follow when handling databases? Definitely. First, always ensure data integrity and consistency by designing a robust schema. Use normalization to reduce redundancy and ensure data dependencies are logically stored. This involves organizing the data into separate tables and defining relationships between them. Second, back up your data regularly to prevent data loss. Implement automated backup systems and test the backups to ensure they can be restored when needed. Third, implement security measures like encryption and access controls to protect sensitive information. Use role-based access control to limit user permissions and secure connections with SSL's TLS. Finally, monitor performance and optimize queries to maintain efficiency. Use indexing to speed up data retrieval and regularly review and optimize slow queries. Keep an eye on database health and resource usage to avoid performance bottlenecks. Thanks for breaking it down, Jaxon. This conversation really helped me understand databases better. Anytime, Aria. It's always good to discuss and clarify these concepts. Plus, it's nice to chat over coffee on a rainy day. As the rain continues to fall outside, Aria and Jaxon feel more confident about their understanding of databases, ready to tackle their assignment with newfound knowledge. In conclusion, databases and DBMS are essential components of modern information technology, providing structured ways to store, manage, and secure data. Understanding the types, fundamentals, and best practices of databases, along with the crucial role of database administration, is vital for anyone involved in IT or data management. Thank you for watching our video. We hope this conversation helped clarify the concepts of databases, DBMS, and database administration.